a random past paper. It's a paper 1 from IB Physics. So I'll show how I solve the first exercises from this paper. Okay, so first exercise, the ratio of the diameter of an atom to the diameter of its nucleus. So what we need to know here first? We need to know what is a ratio. A ratio is when we divide one quantity over another one. Okay, diameter of an atom from the theory is about 10 to the power of minus 10 meters, and the diameter of the nucleus is about 10 to the power of minus 15. So how do we solve it? We just put the ratio of the diameter of the atom of the diameter of the nucleus. So what do we have here? We know that the diameter of the atom is 10 to the power of minus 10 meters. We can add meters here if we need it. And over 10 to the power of minus 15 meters. So meters and meters cancel out. And based on fractions, the power minus 10 minus 15, and it will be 10 to the power of 5. Okay, so which answer will be the right one? This one, 10 to the power of 5. So C is the right answer for this exercise. Next, if we move to the second exercise, let's read it. The kinetic energy of a body is determined from measurements of its momentum P and its mass m. The percentage uncertainties in the measurements are, so momentum is here and mass is here. Momentum is plus minus 3% and mass is plus minus 4%. What is the percentage uncertainty in the kinetic energy? Okay, what do we do here? First of all, we need to combine some formulas here. So first one is kinetic energy, which is mv squared over 2. And the second formula we need to work with is the formula of momentum. So formula number 1 and formula number 2. How do we combine them? So from second formula, we need to rearrange to find the velocity, the speed. So it will be equal with p over m. What do we do next? We just put this formula, p over m, instead of this velocity. So it will be mass times p over m square, all of them square over 2. So using the mathematics further, also fractions, we end up with mass times p square over 2 times mass square. So this and this, they cancel out, and we end up with the formula kinetic energy equals p square over 2m. Okay, what do we need to do next? Next, we need to remember a little bit the theory of uncertainties. So for example, we have a formula A equals B times C, or A equals B over C. It doesn't matter for the uncertainties. It will be error of A equals to error of B plus error of C. And we use the summing here for both formulas. When we have cases where one of the quantities is a square one, then this square, this 2 goes in front of the error. So this will be basically the formula of percentage uncertainty. Now let's apply this formula for our specific case. So our specific case is as follows. Just a moment. So we have Ek equals p squared over 2m, and 2 is a constant. It doesn't have uncertainty, so we don't use it in the formula here. Uncertainty of 2 is 0, so we don't put it here. So uncertainty of kinetic energy will be equal with 2, because it's a power of 2 here, times uncertainty of p plus uncertainty of m. So we have these numbers here, 3% and 4%. We put it in the formula, and it will be 6 plus 4, which is 10%. The answer is B. The correct answer is B. Okay, let's move to the next question. Question number 3. A car travels clockwise around a circular track of radius r. What is the magnitude of displacement from x to y? So first of all, we need to know here what is a displacement. So displacement is the straight line vector that connects the starting point to the ending point. And it doesn't matter the path, it matters only the initial and final position. So initial position is x and final is y. So what is the displacement? Is the line that connects them both. So what do we notice here? We have the radius here and the radius here. Let's say our displacement will be ns. Okay, so this is the displacement. We notice here we have a right angle. It means we can use the Pythagorean theorem. And it is here. S squared equals r squared plus r squared. Using the mathematical formulas, we end up with this, which will be equal to r square root of 2. So which one is matching our answer? It's point C. This is the answer to question number